So welcome children once again. Now today we are studying about the extraction of aluminium, and as you know this is very important part of the metallurgy chapter metallurgy, as now we have only extraction of metals, that is aluminium. And children, in this particular part of the chapter, first of all, as we all have studied in the previous video, that first of all the ore is taken out and the ore is then dressed, or it is concentrated, and then after the concentration of the ore is converted into its oxide, and then the reduction process takes place. You get metal and then it can be purified. So children, when we are talking about aluminium, we'll first of all study about aluminium. As you all know children, its symbol is Al. Relative atomic mass of aluminium is 27 ANU. Its atomic number is 13. So its electronic configuration is 2, 8 and 3. That means 2 electrons in the K shell, 8 electrons in the next shell, and in the last shell we have 3 electrons. And since it has 3 electrons in the last shell, it is a metal and its valency is 3. So its position in the periodic table is that it is present in third period. That is, it is having 3 shells, so third period and group 13 or third A. So this is the position. The specific gravity is 2.2, and children, it is the most abundant metal found in the earth crust. It is 7.4% found in the earth crust, and after that is iron, that is 4.6%. So most abundant. And children, aluminium is reactive metal, so it is found in the combined state. Mostly it is found in oxide form. And children, if you talk about the ores of bauxite, the main important ore of aluminium is bauxite. So the most important ore of aluminium is bauxite, and the formula is hydrated aluminium oxide, Al2O3.2H2. And the next ore is cryolite, that is sodium aluminium fluoride, Na3AlF6, and third is corundum, that is aluminium oxide. Now children, these are the 3 main ores. Out of these 3 ores, this is the ore from where we extract aluminium. And children, when we talk about this ore is containing 60% of aluminium, this compound, and it also contains oxide of iron and silica. So it contains ferric oxide and silica oxide along with this, plus some impurities. So if you want to extract aluminium from bauxite, then it has to be concentrated, or it has to be cleaned, purified. So the very important step after this is the concentration of ore, that is the concentration of bauxite. And this process which we have in the syllabus is the Bayer's process. So in this particular concentration of ore, we are only going to study the Bayer's process, although one more method of concentration is given. So children, in this method of concentration, the first is conversion of impure bauxite to sodium aluminate. So children, this oxide, that is hydrated aluminium oxide, is an amphoteric oxide. Amphoteric oxide, I have told you that it contains the property of both basic and acidic. So since it is an amphoteric oxide, it may react with an alkali. So we are reacting it with concentrated NaOH, and being an amphoteric oxide, it reacts here to form sodium aluminate, a compound called sodium aluminate, and water is released, and rest of the impurities, that is impurities of ferric oxide and silica oxide, are separated out by this process, and they get separated as red mud. So the impurities get separated as red mud. So in the first step, we have converted the bauxite ore into sodium aluminate. And children, in the next step, what we do, we conversion of sodium aluminate to aluminium hydroxide. In this process, children, when we are converting bauxite into sodium aluminate under high pressure, and the temperature should be maintained from 140 degrees centigrade to 150 degrees centigrade. So we get this compound sodium aluminate. And in the next step, children, conversion of sodium aluminate to aluminium hydroxide. What we do, we take sodium aluminate with water, and we even add few crystals of aluminium hydroxide, and we heat it to a temperature of 50 to 60 degrees centigrade. And children, this aluminium hydroxide gets precipitated, or it gets separated out, and NaOH you get out. And children, this process of precipitating aluminium hydroxide, with this process is also called as seeding. So we add few drops of few crystals of aluminium hydroxide over here, and so the crystals develop, and this aluminium hydroxide is obtained. And children, the next step is conversion of aluminium hydroxide to alumina. This is the oxide of aluminium from where we are going to extract aluminium. So this aluminium hydroxide which we have obtained here, we heat to a temperature of 1000 degree to 1100 degrees centigrade, and we heat it to get pure alumina, and vapors of water gets separated. So here we get pure alumina, from here we extract aluminium. Now aluminium can be extracted if we reduce this compound, that means if we remove oxygen from this compound. Now children, aluminium has got a very strong affinity towards oxygen, so the reduction of aluminium oxide to aluminium is not an easy process. So it can only be done through electrolysis. So we do the reduction by the electrolytic reduction process. So children, I hope you have followed this method of concentration of aluminium. Concentration of aluminium is done in 3 steps. We use concentrated sodium hydroxide over here, and we heat it to 140 to 150 degrees centigrade, where we get sodium aluminate. This sodium aluminate compound is formed, and the impurities get separated as red mud, which are the impurities of ferric oxide and silica oxide. Then this sodium aluminate is converted to aluminium hydroxide by heating it with water at a temperature of 50 to 60 degrees centigrade, where aluminium hydroxide and NaOH is again, you get back NaOH. This NaOH can again be reused in step number 1. And this process is also called as seeding, because we are adding few crystals of aluminium hydroxide here in the reactant, so that the other aluminium hydroxide crystallizes out, or seeds can be formed. And children, the next is conversion of aluminium hydroxide to alumina. That is, aluminium hydroxide is heated to a temperature of 1000 to 1100 degrees centigrade, and you get pure alumina. And this alumina is the compound from where we are going to extract aluminium, and that we do by electrolytic reduction. I hope this process, or this Bayer's process of concentration of ore, and it can also be called as dressing of the ore, is clear to you all. Thank you very much.